Dawson, and we are finding x and y intercepts today. And you know, y-intercepts, we've talked about that before, and that's nothing new because we use that a lot when we have slope-intercept form, y equals mx plus b form. And so I want to just review that really quickly, what y-intercept actually means. So when we find the y-intercept, we're really finding the point at which the line crosses this y-axis here. And in this case, the answer is given to us right here. Part of our intercept is telling us what the y-intercept is, which is at 6. So 1, 2, 3, 1, 2, 3. Here's our 6 right there. And then the other part for this one is that our slope is 3 over 1. And so I know for every time I go over 1, I have to go down 3 in this direction. So, or down 3 and then back 1, down 3, back 1, down 3, back 1. And so that's my line. And of course I can keep extending that line. Let me get rid of some of these things. Oops. And that will have this line kind of go off into forever. Well, that's great and all. But sometimes we don't have a choice and we have to find the x and y intercepts algebraically. And you know, if I graphed it, of course I could find the x-intercept. If this is the y-intercept here at 6, the x-intercept is where the line crosses the x-axis. And in this case, the answer is -2. And so my x-intercept equals -2. Oops, not -6. -2. And the y-intercept is +6. Okay, because it crosses at the y-axis at +6 and it crosses at the x-axis at -2. But what if I was given this problem and told to find the x and y-intercept and there was no graph paper? I had to do it algebraically. Well then, first of all, the nice part for this particular form is that my y-intercept's done. I've already got my y-intercept. It's at +6, so that part's easy. But let's look at why that really is, and that'll help us figure out how to find the x-intercept. So when the line crosses the y-axis right here, crossing the y-axis, then it's at +6 on the y-coordinate. But if I think in terms of what is the coordinate point for this, the actual coordinate point here, yes, it's 6 for my y, but it's 0 for my x, and that's always the case. The y-intercept will always be 0 for x, because no matter where the line crosses, if it's going to cross at the y-axis, x has to be 0, because the y-axis is by definition at 0x. And so really what we're doing up here, if we're going to be doing it algebraically, is we can say that y equals 3 times 0 plus 6. I'm just plugging in my x value to find out what the other coordinate is. So that becomes 0, and I'm left with y equals 6. Now we didn't have to do that because we already knew it was 6, but I wanted to show this to you because when we find the x-intercept, we will have to do some math in order to figure it out. Alright, let's get rid of that and let's talk about the x-intercept. So with the x-intercept, the exact opposite is true. Now, when we have an x-intercept at -2, my y will always be 0 because no matter what, when this line crosses at the x-axis, the y has to be 0. So what that tells us, or what that means for us over here, is that if I want to find out what my x is algebraically, which I know it'll come out to -2, but let's again, we're pretending that we don't have a graph to work with. And so if it's -2, if y is 0 at the x-intercept, and that means 0 equals 3x plus 6. And this now is a two-step equation that we can solve for x and find out the value. So if I subtract 6 from both sides, just like we have a million times. We have negative 6 equals 3x. Divide both sides by 3. And x equals negative 2, just like what we found on the graph here. So that makes it really nice. All right, so let's try that one again. And I'm going to get rid of these numbers here. And I'm going to take my line off to the side here. Oops, not what I wanted to do. And then we're going to try the next one without graphing it first. And then we'll try it with graphing. So go ahead and try this one. Try to find the x and the y intercepts for this equation here. You can stop it and try it, and then we'll resume again. Okay, let's see how you did. I'm going to go ahead and start with the y-intercept because it's easy. This is in slope-intercept form, so I know this is my y-intercept right there. So I know my y-intercept will equal 4. Okay, that's great. Now what about the x-intercept? Well, I know that the x-intercept is going to have a y value of 0. So I'm going to plug in 0 here for my y. And that's 1/2 x plus 4. I hate dealing with fractions in an equation here, so I'm going to get rid of this fraction by multiplying every term in the equation by 2, the number in the denominator. 0 times 2 is 0. Negative 1/2, it's going to be negative 2 over 2, which is the same thing as negative 1x. And then this becomes 8. All right, that's the first step. Now I'm going to solve my equation. Subtract 8 from both sides. Minus 8 equals negative 1x. Divide both sides by negative 1. And I get x equals 8. That should be my x-intercept. Okay, well, if that is true, let's see if we got this right. We can go ahead and take our line again. And we said the y-intercept is 4. So I'm going to put my y-intercept up here at 4. It's usually easier for this guy. Okay, y-intercept is up at 4. And my x-intercept should be at 8, which is all the way over here. So 1, 2, 3, 4, 5, 6, 7, 8. So that should be my graph of the line if I did everything, if I did my math correctly. And let's check it. With slope-intercept form, I know it should be y-intercept of 4, so that part looks good. And then it should be negative 1/2. Negative 1/2. So my slope is negative. It's going down. That's a good sign. And then for every time I do a drop of 1, I should go plus 2. Rise over run. Rise over run. Rise over run. Rise over run. Looks like my slope is right too. So this is great. It's another way to do it. And you might ask, well, why would I go through all this work to do this algebraically if I can just graph it and find it? And the reality is sometimes you don't have whole number answers for your y and x intercepts. Sometimes you can have thirds or quarters or something even more random than that. And so it's really handy to be able to do it algebraically and be able to still get a number for your x and y intercept. Okay, let's try in, that was in slope-intercept form. Let's try in standard form now. What if the answer, what if the question was given to us, the equation was given to us in standard form? How would we find that, find the x and y intercepts here? In reality, it's easier. Because let's remember, when we're finding the x-intercept, y is 0. When we're finding the y-intercept, x is 0. So if I want to know the y-intercept, I make x 0. Which effectively makes this whole term go away, because 0 plus 2y, well, that's just nothing, so I don't have to worry about it. So to find my y-intercept, it becomes 2y equals negative 2. Still solve the equation, divide both sides by 2. Y equals negative 1. So my y-intercept is negative 1. And to find my to find the x-intercept, y is 0. So that makes 2 times 0, which is just 0. X equals -2. So my x-intercept equals -2. So it's really fast then. And we don't have to worry about doing much math at all. Same thing down here. If I want to find my y-intercept, x becomes 0. This whole term goes away because 3 times 0 is 0. -2y equals -6. Divide both sides by -2. And my y-intercept becomes 3. And if I want to find my x-intercept, y becomes 0. And that gets rid of that. And that's 3x equals -6. Divide both sides by 3. And I get my x-intercept, which is -2. And so in a lot of ways, standard form is really handy for finding x and y intercepts. And that can be one of the real big benefits of using standard form or solving something for standard form. Okay, hopefully this little video helped you out on x and y intercepts. And I hope you have a good day and that you're learning all kinds of good stuff. Take care, everybody. I will see you in class.